Hello, everyone, and welcome back to the final session of today's AI sessions here at Beltech 2020. This is the last panel discussion of the day, or should I say argument of the day, and I'm very much looking forward to this one. All of the panelists that you can see here on the screen, and Kathy, who's here with me, we've actually all been on panels together before, but we've never been all together in this combination. So I'm quite looking forward to seeing how this goes, because these are my favourite people to share panels with, who are actually always very outspoken. So I think we'll have an interesting discussion, debate, argument, possibly fight. The subject of this panel is on AI explainability. It very much follows on from Fiona's fantastic panel session that she did on ethics. And again, just to highlight to everybody who's viewing at home, please do get in the chat. If you have any questions, just throw it in there. We can actually see the chat as it comes up here. Feel free to ask questions or just randomly insult us if that's the kind of thing you enjoy doing. So I'm going to start off by getting the panels to introduce themselves. And in the nature of real life being better than virtual, I'm going to completely be favourite towards Kathy, who bothered to come into the studio today, and allow her to introduce herself first, and then I'll go to our remote people. So, Kathy?
Thanks, Austin. I'm a professor of experimental psychology at Ulster University. I'm part-time in that role, but my main role is CEO and founder of Incisive. Incisive's a neurotechnology startup company based here in Belfast. And what we do is exploit immersive technologies to help people move better and perform better. So applications in health and sport, really.
Excellent, excellent. Thank you, Kathy. Jace, over to you.
Hi, I'm Jason Bell. I work for a company called Digitalis. We do managed services for large data applications, so mainly bank and insurance clients. And also I am the author of a book called Machine Learning, Hands-On for Developers and Technical Professionals.
Excellent, thank you, Jace. And Andrew?
Hi, I'm Andrew Bolster, and the day job is running the data science team at White Hat Security Europe, which is a web application security and vulnerability assessment platform. And then whenever I have any version of free time, I'm also a founding director and trustee at Farset Labs, the local hack space.
Excellent. And last, but by no means least, Jane.
Hi, I'm Jane Blaney. I'm a lecturer in translational bioinformatics at Queen's University. So I work mainly in cancer research. It's developing predictive and prognostic biomarkers as to how patients respond to treatment. So work across ovarian cancer, breast cancer, colorectal, dealing with large, high-dimensional data sets along with clinical data. So trying to figure out how to stratify patients at the start of treatment, and so improve their recovery and prognosis.
Excellent. Thank you very much, Jane. And actually, that's the area in which I'm probably most experienced, because it's actually the same background as myself, actually. So I'm going to start off with some questions. First of all, we're talking here about AI explainability. What does AI explainability mean to you? How important is it to your organisation? And if the answer is different, how important is it to you personally? And we'll go in reverse order from what we did, and we'll start off with Jane.
Thank you. For me, AI explainability means understanding how a classifier or a predictive model or a prognostic model works. It's understanding the biology of it, what it means, because once you develop a model, say, that predicts how well an ovarian cancer patient is going to respond to a new drug treatment, you may have brilliant classification in one setting, but it's about assay transfer into a clinical setting. So in order to do that, you need to understand what's going on. You need to understand where you've got surrogate variables there that are indicators of a process that's further upstream. So for me, it's not just enough that it works and that it's been validated extensively. As a potential patient, I want to know how it works. I want to know what the intricacies are, and it's, X times, 3 times variable 1 minus 4 times variable 2, so I need to know. I think it's a scientist in me that, it's not just enough that it works. I need to figure out how it works. It's like driving a car. I wouldn't get into a car unless I figured out how all the bits got together. It's not just enough for me to trust that somebody's done a good job. I need to figure out how things are integrated. So for me, I'm always worried that when I validate, say, a prognostic or a predictive model, that something is going to go wrong. I'm always waiting for the next data set where it's going to fail. So there's that reassurance for me that I understand why it's working. So I think in the patient healthcare setting, it's important. Because that can then lead you on to also new treatments. So you may have a classifier, which is more a statistical model that tells you how you can stratify patients, but the actual treatments or the reason why a patient responds really well to a treatment may be hidden within it. So you've got to understand what makes it work. So for me, short answer, I need to figure out what's in the black box.
Yeah, Jen, and I think I've often talked about, the application of classifiers and AI in biology and in diagnostics. When working with machine learning engineers and data scientists, we talk about things like false positives, false negatives, and actually to give them the understanding that, in the space that I come from and that you work in, a false positive or a false negative can result in somebody ending up dead.
Yeah,
and
over treatment, under treatment.
Yeah, and that's exactly the kind of thing where it tends to be an awful lot bigger risk and impact than someone's credit card application getting denied. Andrew, over to you with the same question.
And it's structurally going to be more or less the same answer, but just a bit sort of generalized out. I mean, one of the reasons from a professional perspective why I'm particularly interested in AI explainability is the language that we use to discuss these kind of systems. I mean, AI is realistically just, throw a load of data at some abstract architectures and trust that it's going to be able to at least replicate historical decisions based on whatever the data is. It doesn't actually provide any more information or sort of professional value to the decision-making process until you can actually explain why that AI-derived system came to that decision. As Jane said, even psychologically, we don't trust black boxes. We don't trust just answer machines that go, yep, do this one. We want to know, whether it's as scientists or as individuals, we want to know why a decision was arrived at. But there's more levels beyond that, and this is kind of a mix of the professional and the personal, is that whenever it comes to actually taking some of the powers and strengths of the technologies that we're using in AI and machine learning and applying it at a global scale, we have to fit within the current legislative arrangement. So take the insurance industry as a perfect example of this. You can't just turn around to the Competition Commission and say, I have a black box in the back of our office that says that person needs to pay this much a year and this other person needs to pay this much a year. You need to actually be able to explain and justify how you came to those decisions. This is what we do as humans, and we need to have a similar set of standards for what we expect out of the decision support tools that we're using from a technical perspective. And then just finally, as another one to extend again on Jane's conversation, there was a report that was published yesterday by Gartner that basically said, now that we've had 3 months of exceptional circumstances, that a whole pile of machine learning derived advisory systems have, I would have my own words for this, but to quote it, have gone completely out of whack because unprecedented times throw machine learning models completely for a loop. And if we had a better explainability, we'd be able to combine that with our professional experience and go, oh, here's the actual interesting bit that this ML system arrived at that we can then lift out and make sure that that's resilient to things like the entire world shutting down for a quarter.
Excellent, thank you. First of all, congratulations on being the first person to say the word unprecedented in the session so far. I'm sure it'll be the first of many. And also, I'm shocked and startled to hear you quote a Gartner report. That does not seem like something that you would ever do.
They're not always wrong.
I did an awfully good job of holding myself back there.
Thank you, thank you. No, you don't need to hold back. Jace, you.
For those who know me well and have and seen talks that I've done, most people would know my dislike of neural networks and anything that's black box anyway. Everything has to be explained in some way, shape or form, even down to the training data that's used, because training data itself can create all sorts of bias problems going down the chain. So there has to be a chain of responsibility from start to finish. So the data has to be explainable. The algorithm itself has to be explainable. And that really comes down to reputation of the company providing these services. So my background when it came to data mining was in customer loyalty. I can bore people to tears for hours on this, but I'm not going to now.
Yes, you can.
And thank you. Andrew's been subjected to it. So it does come down to reputational impact, which is why without sort of any form of explainability on the algorithm side, you leave yourself wide open and exposed to media scrutiny. And we've seen a fair share of AI getting it wrong, and companies having to put their hands up. Even recently, we've seen that IBM scrapped the facial recognition program because it just was not good enough. With those kinds of convolutional neural networks, they're really difficult to even go into any depth to explain what the heck's going on there. You just take it at blind faith that something's going to happen and it's going to be correct. Usually, most of the time, it's not. So explainability in AI is absolutely crucial to me.
Fair enough. It's interesting that you mentioned customer loyalty, and I guess since none of you are disagreeing with each other, I might start to disagree. One of the classic examples of AI being considered to go wrong was that classic example over in the US where a girl basically was offered, pregnancy vitamins or something as part of a customer loyalty program.
But that wasn't AI; it was mathematics.
Well, AI is mathematics. But
now we're going to end up on semantics.
But the point is that the explainability of the algorithm or the approach that they used actually wasn't relevant. It turned out it was right. And fundamentally, that's one thing I think is of interest. Is it not more important whether it's right or wrong as to whether it's explainable?
Do you always want to be told the truth?
That's a more fundamental philosophical question.
If we're going to start separating mathematics from AI, then we may as well separate truth from knowledge. It's the issue. If I remember that story correctly, the issue was that it wasn't actually the young girl's problem, and it was her parents. And it was that there was, my daughter couldn't possibly be pregnant. She's a good girl, wouldn't have anything like that. And that was a case where, in this case, we'll say decision support tool rather than AI or ML. It was technically correct, but the ethics of providing that information in that context to that audience was maybe something that required a little bit more nuance.
Yes. Absolutely.
So the target baby stories is what we're talking about here. It was derived from a piece that Charles Doug wrote in the New Yorker about 5 years ago, possibly a little more actually. It goes back to a marketing department decision back in 2002. So it's going back. It's quite an old piece, and the question was, can we, based on basket analysis, figure out if someone is pregnant? And they got it down to third trimester, where they can actually, and it narrowed down to 25 products and behaviors that changed. So customers started buying less scented products or no scented products. Lavender products shot up quantity-wise at that point as well. What happened as a result of that, though, because the calculation itself was, as Andrew points out, it was accurate. They had to start throwing things in like lawnmowers, in the coupons, and the biggest one was opt-in. You have to opt into the baby club, where it's an automatic switch. And that was the thing. So it's down to the creepy line again. At what point do you stop freaking people out? There's a point in time where you're going to do something that's going to freak the customer out based on your decisions. So the baby club for Target was not opt-in; it was automatic. And to what was predominantly not calculated or done at that point in time, the marketing department made a conscious decision to do that, and that's what hacked people off more than anything in terms of being automatically included against their will, because the decision was made outside of their knowledge.
Yeah, and I think, for me, that's always been one of the most interesting stories because of the fact that it's an example where algorithmic determination or prediction of something can be so successful that the people who predict that end up having to fudge what they're putting out there because it's too accurate and it does make people uncomfortable. Kathy, same question to yourself.
Yeah, well, I mean, it's been interesting listening to what everybody's been saying. I think what it really boils down to is what is your system trying to do? I mean, you have to define artificial intelligence in these different contexts. It could be a decision support tool, or it could be making a definitive decision in itself that has huge consequences, such as in the bioinformatics example. That then, for me, would determine the level of explainability. And I know you had given us that sort of little quote around us humans aren't very good, or we can't explain decisions sometimes, and that I totally agree. And I think the big difference here is trying to separate out the differences between human decision-making and machine decision-making. What's the big difference? Humans have emotion, machines don't have emotion. So it comes down to that. Emotion can make us make better decisions, but it can also make us make worse decisions. And I think the current scenario, just to get it back in there again, is around how do you get out of lockdown. So you've conditioned people to be fearful because of the way you've presented the information over the last 3 months. How have you done that? You've focused on death. You've presented numbers as absolute numbers, and I heard a statistician describe it as numbers theatre. So you've conditioned people now for 3 months to be fearful. Now you want to flick that switch and for them to go back. So as a psychologist, we humans are complex. We are complex in what we do. We have our behaviours. And once we establish behaviours, it can be difficult to change those. So I think AI and psychology have a lot to learn from each other. I think as humans, we can make better decisions with machines assisting us to take the emotion out of it, where they could be data-driven, but then vice versa. I think how humans make decisions and how we go about doing our things could improve AI systems by looking at not driving the result through the data, but looking at the principles upon which a decision is made. So what are the determinants of behaviour? What is it that influences that? What are the control laws that underpin our behaviours and our decision-making processes?
Yeah, and it's a really interesting point. For many years, I kind of believed in the idea that when we develop AI, there's almost it's like a get-out clause of we're not developing a decision tool, we're developing a decision support tool. And that always felt like a fairly safe way of saying, well, whatever we're doing here, it's just helping to guide human decision. And it's ultimately human in the loop, human decision. But I actually saw a talk last year or earlier this year by Aaron Peace, who's a cardiologist from the Western Trust in Northern Ireland. He's also involved in CTRIC. I think he's a director up there. And one of the things Aaron was talking about was when we give people decision support tools, quite often we are in reality are making a decision for them. And the example that he gave was ECG algorithms. So ECG algorithms are awful. ECG data is awful. It's messy, it's noisy. But these systems that have been in use since the 70s and have very poor algorithmic decisions basically will give a readout of what they think this is. Is this atrial fibrillation? Highly likely, not likely. And again, these are decision support tools, and everyone knows they're a bit rubbish. But as Aaron said, when you get to a point where you've got a fairly junior doctor who's coming to the end of a 16-hour shift, 99% of the time, they're agreeing with whatever the computer tells them. And I think that's something we do need to be very wary of from an ethical perspective, and Fiona's panel earlier, and from an explainability perspective of, honestly, and again, something I've completely had a turnaround on. I always did believe in this concept of it's decision support, but I think we have to realise when we implement these things, it's not decision support. We're ultimately making decisions. It'll probably be an exception rather than a rule that people disagree with what the algorithm tells them.
So does that become a data quality problem?
100%.
And not a decision?
Well, I mean, ultimately, I think that's one thing I don't think any of us will disagree with, is that ultimately all of the problems, the vast majority of the problems in AI machine learning are based on data quality. Yeah. Bias.
Well, I mean, that opens up a really dangerous preposition because all of these AI and ML systems are built on training data, and a good ML system is based on feedback of its decisions, where you're going, right, how many times did the 16-hour shift doctor agree with the ML itself? So if we're turning around and saying, right, okay, we no longer trust the subject matter experts to accurately react to the decisions that come out of this tool, then we effectively have to throw away the entire field.
So I've seen in a couple of places systems introducing like an external betting engine to actually bet on the prediction, and then to qualify that prediction whether it was correct or not. Those kinds of bets are interesting to me. It's something I've been researching quite a lot over the last year or two. That how we arrive to those decisions. And that kind of thing with a betting engine has been interesting to me in terms of neural networks as well. How do you tighten them up?
I'd like to go back to Andrew's point there about the data. Andrew, why does it have to be data-driven? I mean, if you look at the Tesla, the first car, it was based on 780 million miles of driving. Compare that to like a learner driver. So one of our interns has gone for a driving lesson this morning. He might have 10, 15 lessons before he does his test, and he can drive perfectly well. So he doesn't need 780 million miles of data. Why? Because the human brain doesn't work on a bottom-up data-driven approach like that, where you have to then do trial and error and learn in that way. It's based on a totally different system where it's about the perceptual input being processed and driving the behaviours and the action output. So I think by flipping things around and looking at how do humans do this in a parsimonious way, I think computer scientists and AI could advance a lot quicker. And I know EPSRC was looking at this a few years ago because they asked me to be part of the human-like computing panel. And I think if you look at how biological systems have evolved over millions of years, they've come up with extremely smart, robust ways of doing it. And whilst people think, oh yes, you know, we have occasional accidents, if you look at the people driving per day, I mean, it's relatively relatively extremely few accidents happen in comparison. You know, so I think there is a different way of looking at this. Why does it always have to be putting loads and loads and loads of data in? Why can't the learning be different? And why couldn't it be driven by sort of like a law-like way of how information influences in context? Because I think a lot of these things, and if you look at robotics, Boston Dynamics, they're very good at creating robots that can respond to static situations, jump onto that chair, but they can't play football. So you can see 2-year-olds, 3-year-old kids play football, but get a robot to do that in any sensible way. And what's the big difference? The big difference is there's unpredictability, there's context, you have a moving ball and moving pieces. So I think this requires a bit of a change in the conceptual framework of like AI, and can you not go for something more overarching rather than one system that's designed to do one task and one task only, like AlphaGo that can play the game Go, but it can't move the pieces, you know. So
I think that
as an opportunity to respond, because it was called out. The first thing I would say is we've had artificial intelligence and general artificial intelligence for hundreds of thousands of years. It's called children. And having children.
But it's not artificial.
Putting them on,
there's nothing artificial about it. It's called intelligence, you're right,
yes,
but it's not artificial.
Yes.
It's not artificial. Artificial means it's not real.
Okay, well, we can drift onto the semantics another way. The issue is that all of the things that are currently being approached for AI support, so medical imagery support, reading ECG, these aren't things that are magical new devices. Driving cars, as you say, is not a new thing. Your intern's going and learning how to do it today. The issue is that if I want to have 500,000 cars driving at the equivalent level, I can't copy and paste your intern once he's trained. Whereas once the investment that goes into these tools is done, then you have, if we have explainability, we have a consistency of decision making that's scalable at more of a human level. I mean, the ideal solution, if we want to go down the path of emotional intelligence as a decision making support, is that we'd hire more people and just train up more people, and we'd throw away the scaling opportunities of the machine learning platform. My philosophy on sort of the push for AI, I don't think generalized AI is going to be within our lifetimes at all. As you say, we've got ML tools that can drive cars but can't kick a football around. You're completely right that we don't have that capability of generalized support. But the reason why we're investing in and researching these AI and machine learning technologies is to scale out the human dependencies and provide sort of bulk decision support.
Okay, Jane, you wanted to come in there?
Yeah, I mean, it's going back to this idea of the data is the issue. The data is the issue in the sense that it's what you base your clinical or biological hypothesis upon. If we're designing an experiment, we have to have a question that we're trying to answer. Not all data sets are going to be appropriate to answer that. Plus, I would have issue with the fact that machine learning is the only way forward. Not all modeling approaches match the data. Neural nets aren't going to be appropriate for every data set. And sometimes I'm worried, well, in fact, all the time I'm worried that people are going away from more simple approaches like logistic regression, linear regression, where you need a smaller data set which you can curate, and it tolerates missing data, and it's more explainable. So I'm often worried where the actual answer is possibly sitting there already, and people are way off playing with new toys. It's like some of the more recent, competitions or hackathons. People were saying, oh, yeah, we've built a great machine learning model. Then we actually look at it and go, mate, you've just used logistic regression.
Yep.
And you even check for assumptions. And it's almost like machine learning is there as in, ooh, this is playable with, this is new bits of Lego, as opposed to, look, would you start simply and try and build the complexity up? And we may not be able to model, say, the short circuits that go on within gene-based networks or pathways. We may not be able to do that with some of the more simpler models, but I think you have to start somewhere, and also realize that with the data sets that we have, we may not know all the information to record. If we knew all the information to record, we'd be partly there towards answering our questions. You're dealing with incomplete data, as in, somebody may have missed out measuring blood pressure, but blood pressure is the integral thing that makes a diagnostic or prognostic model work. So it's accepting that our data is incomplete because we haven't recorded everything. We maybe have chosen the wrong patients. But I think for me, it's like when people get excited about machine learning AI, it's like, whoa, hold your horses here. Let's go back to basics. Let's see what we can extract from the data in a simple process and start to build in those levels of complexity later.
Absolutely. And I know that this is a panel that will disagree a lot, but I think that one thing that literally all of us will agree, and that question one should always be, can I do this with logistic regression? Does anyone disagree with that?
No, not at all. I mean, actually, if you I was just about to say I completely agree with what Jane said there. I mean, if you go back to the Beltec talk that I did in 2018, I got the audience to bet on logistic regression, a decision tree, and a neural network. Traditionally, neural networks were always the one thing you did last because no other algorithm at the time gave you a sufficient result that was usable. So you then piled everything into a neural net just to see what would happen. But what's happened is that the media has given us the joyous coverage of neural networks to say these are going to change the world. Companies have jumped on those, started using them with any form of research. A bit of a sweeping statement, I apologize, but it's like, oh, we're going to do AI now, and everything goes onto a neural network.
TensorFlow, all of the things.
TensorFlow, all of the things. How did that trial go, Austin?
Oh, it went really well.
I mean, it kind of goes beyond that because you say it's been applied to all the fields, but realistically, whenever people say, oh, we've launched a brand new AI system, I guarantee you in 99% of cases, it's object detection in pictures and natural language processing built off the shelf ImageNet and GPT models.
Yes.
The vast majority of things, whenever individuals or companies report that they are using AI, it's the majority of cases can be covered by the one-page AWS documentation tutorials.
I think it's okay to play with data. I mean, I think if you have the luxury of having time to research, and you're not a patient isn't maybe waiting on a result. I think once you have a result, like say using logistic regression, as a scientist, it's up to you to kind of figure out, can we do this better, and can we do this better consistently? So I think it's okay sometimes to take like a more kind of playtime and let's see if this works. But it's recognizing that it's not always going to work. And it's what also worries me, and it's like a Daily Mail headline. A lot of the funders are going towards this now, and the joke is apply saying you're doing AI, in the paper say you're doing machine learning, but actually in reality you've used logistic regression. And that is just scary. It's like, okay, it's the emperor's new clothes here. Where is it appropriate? When is it appropriate? And do people who are actually using these systems actually know what is happening? Know how to use it, know when to use it, know what parameters to choose. It's not just about clicky button time. I think people are too click happy at the moment. Oh, look, I got a prediction. Play it.
Can I just check, are you talking about AI or blockchain? I forget.
Wow.
I mean, it actually kind of goes fundamentally to the question about this panel. And this panel is called AI Explainability, and I'd love someone to explain and actually have an agreed upon definition of what we're counting as AI, what we're counting as machine learning, and what we're counting as data science.
Yeah,
and
totally agree.
I think
have that conversation regularly.
Data science. Somebody, my old PhD supervisors came up with the definition that data scientists are ones that couldn't be bothered to learn proper statistics.
As the data scientist on the panel, I both completely agree and take personal umbrage at that one. But
this is great. This is the first panel where Andrew and I are arguing, but he's arguing with everybody else.
You set the scene well. You primed me for that one.
But so, folks, honestly, I knew that I wasn't going to have to ask many questions in this one, but I do want to force in one last question, and I'm pretty sure that'll eat up the rest of the time, okay? And I'm sure you can guess which one it's going to be, and you alluded to this one already. So in 2018, Jeff Hinton, who is the father of convolutional neural networks and obviously has a bit of a vested interest in this, he basically made a comment in an interview in Wired magazine in which he stated that basically AI explainability is a complete red herring. We as humans cannot explain how we make decisions. So why are we insistent that our machines should have to do the same thing? And fundamentally, it is about humanity and brain chemistry. My decisions are going to be impacted by how much sleep I got last night, whether I had a few glasses of wine last night, what I had for breakfast, if I've eaten in the last 6 hours. There are many different factors that I have no control over. And we could even get into a philosophical debate over free will generally and whether how much true agency that we have as humans. And we could talk all day. But the question is, when we already know that there's such a philosophical and psychological debate around how humans make decisions, why do we expect any good AI to be explainable at all?
But what you're talking about, the lack of sleep or what you ate the day before, those are variables that we don't know to record. And it's a similar situation with the data sets that we have about patients. We haven't got the full amount of data, but if we observed you over a matter of days or weeks and had replicates of you, we could adjust for all those unknown parameters. So it's not just about taking you as one kind of use case. It's about looking at you over a period of time. And, you're talking about kind of decisions which have been hardwired. If you think about a pathologist who would understand why they're making that decision, but like 20 years in the business or 20 years in their training, it's become almost like instinct, like a gut feeling, which they can't explain away. But maybe at the start of their career, they could.
I agree, but actually the fact that you mentioned pathologists is a really good example of that, because there have been multiple studies done showing that pathologists' consistency in decisions is incredibly poor. Examples where the same pathologist is given the same sample 3 times, 3 different weeks, and given 3 different results. And again, the explainability of that decision is clearly very dubious because they're giving you a different decision each time. And often when we talk about this, it tends to come down to this: if I can't explain how my AI works, it's no good. We should just resort to human decisions. But we know humans are really bad at making decisions. We're not good. So why do we place more emphasis on machine explainability than we do on human explainability?
Because we've all watched Terminator. That's it. We're scared of the machine, and to take the driving example that we were discussing earlier, for me as a non-driver and a consummate cyclist, walker, and public transport user, I am much more afraid of your intern your intern going on the streets than a Tesla driving around, because it has the cumulative experience of hundreds of thousands of different roads, whereas your intern knows about the Tesco car park. And this idea that AI needs to be able to explain everything, I personally believe it's aspirational, and it can be down to even saying, I, as the AI, made this decision based on an edge case that I saw on this data set that was over here, and it was like however many years ago of relative data. I mean, I think we do need to, as part of for the people who are building these systems, we do have a certain responsibility to not necessarily work out how do you explain to the lay person how you came to that particular decision, but at least being able to have the traceability of saying, I learned to make that decision based on this subset of data, and effectively to be able to give evidence of why your decision is correct, not necessarily going down the full hypothetical decision tree of variable X greater than 0.7, variable Y less than, whatever. And being able to explain by example is a really powerful way, because we learn by example. Humans learn by comparing two things and going, okay, those look close enough, so I understand that they're part of the same set. And one of the things from an overall perspective, I think the year that AI research was fundamentally shifted was 2014, in the publication of Ian Goodfellow's generative adversarial network paper, where it's this idea of we have a model, and we'll go for the infamous one, which is detecting cats on the internet. We have a model that we want to train to detect, does this picture contain a cat? Then to generate that, we either create loads and loads or curate loads and loads of labeled data. Just Google around and find people's cat pictures. Have humans train those, label those manually. But what Ian turned around and did was basically, right, okay, I'm going to turn this idea on its head and go, I'm also going to create another network going the other direction, saying, dear network, make me pictures of cats. And feed that into that pipeline. And by having those two opposing models with slightly different optimization hyperparameters, you end up with two processes. So to take this back to our original point, if you have a AI network or a machine learning network, or even if it's a logistic regression, you need to have some kind of model on the other side. Again, whether it's ML, whether it's just having, pointing to the logistic regression Wikipedia, you need to have some justification of why your tool operates in that way. In my ideal world, it should give evidence, but we should at least be trying.
Yeah, I think it's really... Sorry, Jen, please.
No, I think with the models, like the pathology, the labels come from humans. You need some sort of ground truth. And humans are terrible at saying, I don't know, I'm not sure. And if you force a human into making a decision, and again, it's based on what they maybe see or what they had or had not for dinner, I think humans need to be able to kind of go, you know what, there's a big grey area here. I can detect extremes, but there's a group of cells here that I'm not sure about. Yeah. And I think it's when you force people into making that's when you get, damage potentially for patients.
Yeah, and I've been involved in projects where we've developed classifiers that got 90% accuracy, but when we went in and looked at the cases where we were wrong, it turned out that the label was wrong every single time. So we probably had 100% accuracy, but the ground truth was incorrect. Kathy, it's not often I get to share a panel with a psychologist, and the question I just asked obviously has a lot of brain chemistry and psychology involved. What are your thoughts on this?
Yeah, it's a very, very interesting question. And of course, I said earlier that we are notoriously bad at making decisions. I still disagree with Andrew. I think my intern is a much better driver than the Tesla car. Why, Andrew? Because he'll be able to deal with those unpredictable things the Tesla car has never seen. So the ball that comes out into the road and the 5-year-old that's going to chase the ball, somebody will recognise the potential danger because you use heuristics, you use inference, you use things that machine learning isn't adapted to use. And that, for me, is the type of intelligence and knowledge, whatever you want to call it, that we bring to bear on all our decisions. We'll always use context. Again, it's back to what Jane was saying earlier. It'll be will this person die if I do this, or will this person survive? And if you present it, Tversky and Kahneman, who won the Nobel Prize for economics quite a few years ago, showed these psychological studies. You can present mathematically exactly the same data in two different contexts, and you will influence the decision that somebody makes. Whether it's a loss or whether it's a gain is going to influence the decision that this same person will make. So we're notoriously bad at reasoning and rationalising these things, and our perception of risk is atrocious. Yeah. So I think it's back to that. How can we use the advantage to our advantage machines, use AI to support decision making, but not have that over-reliance on it? And that's where I think the explainability for this has to come in. As a human, you want to know, how did you arrive at that decision, just so you can understand the weaknesses in your own decision making. So if you were using all these numbers, and I think it comes back to how we approach psychology. We approach with hypothesis. So we cannot test everybody in the world. And in fact, a lot of psychology has now been criticised because it's always based on sort of white middle-class Americans of samples of 20. And again, it's back to where the advantages and the things going forward. It's back to all those data points we can now capture about behaviours, about sleep, about nutrition, about weight, about all those other things that could be affecting your life or predictive of future disease or different things. I think that's the exciting thing. And that's where big data or whatever you want to call it, machine learning, whatever comes in. So, yeah, I think the two disciplines need to come together. I think we shouldn't say humans are bad at making decisions or machines are bad at making decisions. They both have their strengths and weaknesses, but let's strengthen human decision making by using the strengths of the AI, but equally let's improve AI by using the strengths of human decision making. That's the way I see it.
Which is why we've gone into a lot of poker AI recently over the last couple of years, because they're incomplete information games.
Yeah, absolutely. One final point, actually, that wasn't in the questions I suggested, but I'm actually just curious on your thoughts on this one. I don't know if any of you have read The Book of Why by Judea Pearl. Really interesting piece in which I think it highlights, a lot of the points that you've just made, and I think this is an area that's always kind of fascinated me. He argues that one of the biggest challenges with machine learning and AI that has held it back is statistics. Statistics has messed us up because statistics is based on the idea that we can never understand what causes something, we can only understand correlations. And he basically maintains that by what we should be focusing on is not correlation, it should be about causal inference. And if we focus on causation and trying to understand causation, the data that we require is significantly less or significantly different. And I was just interested in your thoughts on that idea of causal inferences versus correlation.
And so from psychology, I'll just say correlation doesn't mean causation. That's what
Absolutely.
we teach our students in statistics right from day one. Yeah. And that's why we tend to use hypotheses. We've got independent variables, our dependent variables. We manipulate our independent variables, so whatever our conditions are in our experiment, to see the effect. And I think that's where AI could greatly benefit. So you have a different data set. Let's manipulate that independently to see how well it deals with different data.
Absolutely.
It's still only looking at data. I mean, even with statistics, what I try to get across, as well as what Kathy was saying in terms of, correlation does not equal causation, but it's also saying to them with a particular stats test or stats modeling, you're only looking at the data in a particular way. So that's, you can keep turning it and, looking at it from different angles. For me, in terms of this causation, we're missing factor X, factor Y, factor Z that we haven't recorded about the data. The data, always assume the data is incomplete. We don't know everything that we need to record. So in terms of causation, you could, to me, like say, in a biological extent, it could maybe suggest what is happening, but you need to go into the lab then to actually test it. So I don't think we could ever do anything with numbers or with models that could imply something that we will always have to go into the real world, whether it's in a lab setting, whether it's in a human setting, and say, okay, let's see what happens when we push this. It's like Jenga. If we take this stick away, what happens?
One of my personal big bugbears with this field as a whole is that, one, I think I speak for everybody on the panel, where none of us believe that data is infallible. Nobody's following the church of data, and unless we're talking about Star Trek philosophies. But, nobody's saying the data is always right. The data indicates something or may be manipulated to indicate something. And I mean, one of the reasons why I always try and push for the term data science rather than machine learning is that we should constantly be suspicious of our decision support tools or whatever we're going to call them. And we should constantly be, as Jim was saying, jangling, breaking them, manipulating them, trying to find out, can we make them better or more explainable or simpler or quicker? And I think one of the things that for me differentiates or is a big red flag whenever I see it in far too many places is whenever there isn't that feedback loop, because that feedback loop means that you generated a model, or not having that feedback loop means that there was a model, a regression, a function effectively that was written once, arrived at once, and it passed some statistical measure of accuracy at the time based on a certain subset of potentially biased data, and then it was deployed to production and continues to be used to this day.
Yeah.
And without that feedback loop, that indicates that there isn't a constant monitoring and interrogation of the operation of those tools. And without that constant interrogation, monitoring, and kicking around, frankly, we cannot over time build confidence in our decision support tools.
I mean, ultimately, bottom line, it's a great final point there, Andrew. I mean, this is all about trust and confidence and suspicion, and we should always be suspicious of these systems. We've already overrun by 10 minutes, actually, but until someone yelled in my ear that we should wrap up, I decided I was going to let this go because I'm enjoying it, but I now have had someone yelling in my ear that we need to wrap this up. So I just want to say thank you very much, Kathy, Jace, Andrew, and Jane. That's been a fantastic panel, and to invite Fiona up to just finish us off.